Let us continue with e-commerce application and possible components of multimedia. Now, moving to the next slide. So, we are having the working perspective. Okay, we have seen several application anatomy of e-commerce in our previous sessions. Now, moving to the next session, okay, which is nothing but your e-commerce infrastructure. So, multimedia contents for e-commerce applications. So, multimedia is both equivalent traffic of e-com applications. And whenever we are dealing with technical definition, use of digital data in more than one format, such as combination of text, audio, video, and graphics in a computer file or document. So, what are the possible components of multimedia? So, whenever we are dealing with possible components of multimedia, we are having text, images, audio, video, animation, hologram, and numerical data and graphics. So, these are the possible components of multimedia. So, multimedia contents of e-com applications. What are the contents we are having? So, whenever we are dealing with multimedia, so multimedia mimics the natural way of how the people will communicate. So, thus many managers, okay, charting strategic directions now ask, okay, which sort of applications we are using the multimedia and will have the greatest impact on their particular business operations. So, the traditional separate business divisions presented, okay, in this particular diagrammatic representation. For instance, an electronic book no longer text only offer includes photographs, voice, video clips, animations, and a host of the other things. In other words, every form of content is interrelated to other forms. So, the purpose of multimedia. So, whenever we are dealing with the purpose of multimedia, it is combine the interactivity of the user-friendly interface with multiple forms of contents. The multimedia is associated with the hardware convergence taking place in the telecommunications, computer, and cable industry. So, it has come to mean the combination of computers, televisions, or telephone capabilities in a single device. We can able to justify what is the purpose of multimedia. So, what is the goal of multimedia? To increase the ability of all information through the processing and distribution of new forms such as images, audio, and video. So, multimedia represents a next generation of computing, and also it covers so many things that is often difficult to conceptualize. So, telecommunications, cable and broadcasters, computer softwares and hardware providers each have a different view of what multimedia means. Each and everything we are having a separate view. So, whenever we are dealing with the contents of multimedia is related to e-commerce, then in multimedia, every form of content is interrelated to other forms. Example, suppose you are taking electronic book, content, text, photographs, voice, video clips, animation, host of other things. So, access to multimedia content depends on the hardware capabilities of the customer. The key issue in e-com development, what does the consumer want? We have to based on the we have to first we have to know, and then we have to satisfy the customer needs. So, no one could develop the killer application for e-com until the technical infrastructure is in place, clearly defined, or at least articulated. The success of e-com applications also depends upon the variety and innovativeness. Okay, wherever we are having innovative things, okay, to be done, then we can able to sustain in market. Otherwise, that demand of that particular product we have to think of. The advantages goes to the current providers, okay, which is nothing but packages of multimedia content to entertainment, broadcast TV productions, traditional print publications, and software and information services. Moving to the next slide. Okay, e-com requires robust servers to store and distribute large amounts of digital content to consumers. So, these servers are large information warehouses capable of handling various content like books, newspapers, advertisement, catalogs, movies, games, X-ray images, etc. So, these servers must handle large-scale distribution, guarantee security, and complete reliability. So, whenever we are thinking about the large scale distribution, we will call that as a warehouses. So, whenever we are speaking about the warehouses, so multimedia storage, servers and electronic commerce, we will speak about the warehouses. So the digitized content eliminates the bulkiness and mechanical unreliability found in past equipment, whatever we are having, and steady advances in digital memory technology, are making the mass storage devices technologically feasible and increasingly the cost effective. For example, with the 256 megabyte and 1 gigabyte memory chips now under development, an entire feature length movie could be stored on 4 to 10 memory chips. So frequently requested or accessed content will be stored on such relatively expensive chips, and the content requested less often will be housed on less expensive media such as optical disc or magnetic tape. So this is an example. So all e-com applications follow the client-server model. So for each and every electronic commerce application, we are having a client and server model. So clients are devices plus software that request information from servers. The dominant model of client-server architecture links PCs to a storage or a database server where most of the computing is done on the client. The client-server model allows the client to interact with the server through a request-reply sequence governed by message passing. Either it can adapt a transmission control protocol for the communication, where we are getting acknowledgement for each and every message, whatever we are sending in the network. Then server manages application tasks, handles storage and the critical elements like distribution, connectivity, security, accounting, and provides scalability over a different aspect. Server is expected to simplify and make scaling more cost effective, and client devices handle the user interfaces. So now coming to the client server architecture in e-com applications. So what do you understand by client server architecture? So we can aware of this particular client server architecture before itself, because we are dealing with networks. In our previous semesters, we have studied a lot about the concept how the networks will function. The commercial users have only recently begun downsizing their application to run on client-server networks. It is a trend that e-com is expected to accelerate. So we are having application logic, we are having a presentation logic, then we are processing the request. Here also in multimedia server, we are having application logic and multimedia content. So multimedia content we already discussed in our previous slides. What is meant by multimedia and how the content of multimedia will be. Then the result is processed. Again, it is written back to the multimedia desktop. So this is a distribution of processing in multimedia, how the client and server will communicate. So however, that the full impact of the fundamental shift in the computing will result in a host terminal architecture to a network client server architecture. So whenever we are thinking about the client server architecture, will take several more years. To be realized. So there is a long way to go. Before the installed base of mainframes and mini computers is networked or replaced by workstations and PCs. So commercial users have only recently begun downsizing their application to run on client server networks, a trend that electronic commerce is expected to accelerate. Then moving to the next slide. The internal process involved in the storage, retrieval and management of multimedia data objects are integral to e-com applications. The multimedia server is a hardware and software combination. So whenever we are speaking about the multimedia server, we will concentrate on both hardware and software combination that converts raw data into usable information. So whatever the data we are having is a raw data, can be converted into usable information and then distributes it to users where and when needed. So where and when needed, we are going to distribute the information. It captures, processes, manages and delivers text, images, audio and video. So most multimedia servers provide a core set of functions to display, create and manipulate multimedia documents, to transmit and receive multimedia documents over computer networks, to store and retrieve multimedia documents. For this we needed a complete storage system for storing our documents. So now we are moving to the internal process of multimedia servers. To make interactive multimedia a reality, a server must handle hundreds of simultaneous users. For handling the simultaneous users, first we have to possess a proper bandwidth. So manage the transactions of the users, purchases, specific information request and customer billing. So deliver information streams to consumers at affordable cost. That is most important factor we have to analyze. Then we are having traditional models versus new models. Technical challenges whatever we are facing in the e-commerce. So data difference, no longer table formatted alphanumeric data. So old computing platforms pose bottlenecks when trying to deliver large pieces of complex data. Since 90 minutes video consuming over 100 gigabytes of storage space requires a platform that includes high-end symmetric multiprocessors, clustered architectures, massive parallel systems. Like this, we are having several complications. But nowadays, we are overcoming that. So economical storage and manipulation of digital video is possible only with several magnitude of compression using video compression standards. So we are having lot of video compression standards. In that most prominent one is Motion Picture Expert Group, which is nothing but MPEG. So video servers and electronic commerce. The need of large-scale video storage has led to new video servers. Okay, the need is keep on increasing year to year. Okay, the need is keep on increasing year to year. So whenever we are the need of a large-scale video storage has led to new video servers. So whenever we are speaking about the need, the need of large-scale video storage is keep on increasing year to year. So video servers are important link between the content providers, entertainment or media, and transport providers. Okay, we are having wireless or cable operators. Okay, like this, we are having several communication systems. So video servers, unlike client server systems, deliver information to hundreds of consumers simultaneously via public telecommunications and cable networks. To make a video available to numerous households, we will call that as a broadcasting. Either simultaneously or at overlapping times, hardware or software solutions can be used. What is meant by hardware solution? So use power of massive parallel architectures. Okay, each processor acts as a video pump and distributes a portion of the film so that a single film can be viewed by numerous households on demand. For example, N-Cube video servers with 512 processors, each equivalent to Intel Pentium chip and RAM of 16 gigabytes, is a valuable example. Then coming to the next point, which is nothing but software solutions, we will have a Microsoft Tigers based on Windows NT-OS. So implemented on PC for individual work group, as corporate servers for small, mid-sized private network, and as large servers for large-scale consumer use. So it is a goal to provide the power and functionality, scalability to give users split second access to thousands of media files, whatever we are having the servers, and to allow lesser distinct functions, which is something like pass, reverse, fast forward, and jump ahead to user specified locations. Then coming to the block diagram, which is nothing but generic video on demand system, we are having a subscribers and video server, which is nothing but a wholesale or distributor, video encoder, data compression unit, and cable TV and satellite based or other hybrid delivery and router systems. We are having billing and accounting based on our usage, and programmer or service selection interfaces. Okay, set top selectors we are having. So these are the simple concept behind the block diagram of generic video on demand systems. So whenever we are speaking about the generic video on demand systems, so what is the basic thing we are having in this means the electronic commerce application related to digital video will include the telecommuting and video conferencing and geographical information systems that require storage and navigation over maps, or corporate multimedia servers, or we can say that as a post-production studios and shopping kiosks. The consumer applications will include video on demand and a range of interactive services such as shopping. Okay, what is we can understand the things, okay, while we are going with different analogies, whatever we are going to see in our future slides. So the need of large-scale video storage has led to a unique business partnership between the technology and transport and media companies in interactive TV trials has resulted in development of new video servers. So like this, okay, we are seeing a lot of examples for video on demand systems. Why the video on demand is necessary and why we are going for a differentiated billing and accounting servers. So based on our usage, we are going to charge. So video servers, okay, we are seeing video server architecture are an important link between the content providers, okay, entertainment, media, and the transport providers, which is nothing but the telcos, wireless, cable operators. And one important difference between the video servers and the current client-server computer systems used extensively for data processing in the video servers are designed to deliver information to hundreds of consumers simultaneously. Either we can follow the methodology of broadcasting or we can follow the methodology of multicasting. So video servers tackle the simultaneous overlapping supply problem that arises when providing on-demand services to large number of houses. So whenever we are speaking about the concept behind the supplying, okay, whatever the video on-demand requirement, that we have to think about how to meter and how to bill based on the each and every individual consumption. So numerous households, okay, will want to consume the so whenever we are thinking about this problem can be approached from either the hardware or software end. Then coming to the e-com infrastructure, information delivery, transport and e-com applications. What are the principal transport providers we are having, which is nothing but telecommunication, cable and wireless industries. Then computer networks, commercial networks such as computers, servers and America Online, public networks such as internet we are using for the effective communication. The transport system does not function as a monolithic system. The architecture is a mix of many forms of high-speed network transport, whether it be land-based telephone or air-based wireless or modem-based PCs or satellite transmissions. So transport routes from e-com application are boundless. So here we are having two tabulations, okay, information transport providers, information delivery methods. So telecommunication companies, long distance telephone lines, local telephone lines, and cable television companies, cable TV coaxial, they are using fiber optic cables for sending the data from one end to other end, and satellite lines. Then coming to the computer based online servers and internet, which is something but commercial online service providers. Then we are having wireless personal communication services, cellular radio networks. Okay, whatever we are seeing, for a better example is a paging systems. So coming to the currently, we are speaking about, whenever we are currently speaking about the basic concept of these particular information delivery and transport and e-commerce applications. Whenever we are speaking about the e-commerce applications, you can say that currently about 65% of e-com applications are delivered online via computers equipped with modems. Because people want to know about the things, okay, in the home itself. They want to learn lot of things using the internet. So percentage of information delivered on CD-ROM still continues to grow, and information delivery by telephone, audio text is a promising medium, okay, where we can easily communicate with one another without wasting the time. So whenever we are having a transportation, intermediate transportation, okay, whenever we are going from one place to other place to see one person, means it requires, okay, a lot of fuel consumption. You have to take your vehicle and you have to reach out that particular end to see your friend or relative. So the next generation of delivery media is expected to be interactive multimedia, which is nothing but computer plus telephone plus television services. So distribution of information has become a competitive market, playing on the defense. Telephone companies and cable television companies that have enjoyed a monopoly from decades. So whose enormous wiring and equipment have become vulnerable to new competitions. And playing offense are the computer companies that offer new hardware capabilities and software programs, and banking on public networks such as internet. So another emerging threat will be the wireless communication or personal communicators that bypasses traditional telecom companies and use wireless communication. So this is a concept which is coming under the information delivery and transport and e-com applications. Then challenges to router providers. What is the actual challenges the router providers will face? So first one is telecom. So most visible and vocal. Then include long distance and local telephone service providers. Then ADSL, which is nothing but asymmetric digital subscriber line. So technology which squeezes a video signal through a telephone wire, which is nothing but ADSL. The ADSL cannot handle live transmissions and picture produced is not clear. So recently picture quality is improved with further compression several channels. Okay, compression, we are having a lot of compression standards. So with further compression, several channels of a live video over a single telephone wire can be accommodated. Then coming to the cable-based systems. Okay, what do you understand by the cable-based? Telecom-based, we have seen a little bit concept. So the technology known as asymmetric digital subscriber DSL has come unresolved drawbacks. It cannot handle live transmissions, so the picture it produces is not as clear as that provided by the well-tuned cable hookup. So researchers have recently improved the quality of the picture with further compression expected to accommodate the several channels of live video over a single telephonic systems. So cable based, whenever we are coming to the cable based systems, the providers depend on coaxial cable as transport routes and with help of determine which broadband application services the viewing public preferences. So all leading cable providers are conducting trials with the variety of hardware and software, and most are expected to use a fiber optic cable and coaxial wire as a delivery medium. The strategy among the cable companies is to develop a network neutral content that use digital compression and is adaptable to alternative delivery systems. So this is a concept behind what we are seeing in this. The strategy among cable companies is to develop a network neutral content. Okay, a few minutes back we discussed that. Coming to the computer network base, these providers are often dial-up linkages of lower bandwidth when compared to telecom and cable highways. So bandwidth, whenever we are speaking about the bandwidth in analogous to the number of lanes on a highway, so we can take the examples of online transport architectures also we can consider. Then coming to the wireless based system, these operators are typically radio based or cellular or satellite or light based, infrared. So in fact, some of the most exciting transport architectures are invisible. So new wireless based systems require new ways to communicate. So personal communicators, couple cellular phone with pen computer user interfaces, a cellular phone with pen based display instead of standard keypad. Okay, whatever we are having includes many functions such as fax transmission and reception, email, and limited personal information management. So these are the simple personal communicators whatever we are having in this particular e-com applications, how we are going to deliver the information or transport the information in proper way. Then coming to the consumer access devices, the way majority of users will access e-com applications is heavily linked to the access device opted for use. So information consumers access device. So computers with audio and video capabilities. Okay, we are using personal desktop computing, workstations, multimedia PCs, mobile computing, laptop and notebook, CD-ROM equipped computers. Then we are coming to the telephone devices, which is nothing but your video phone. Then consumer electronics, television plus set-top box, gaming systems, and personal digital assistants, which is nothing but PDAs, pen-based computing, voice-driven computing, software agents. So these are the consumer access devices. Now coming to the interactive TV has been what do you understand by interactive TV? So whenever we are speaking about the interactive TV, okay, whenever we are speaking about the interactive TV, So the TV has been touted as a information access device of the future. Okay, the interactive TV is a access device of the future because almost everyone has TV and comfortable in using computer. So also advances in computers making it much easier to operate, more useful, less expensive. So all are having TV in their homes to see. They are seeing lot of things, okay, and learning some more things from either they are seeing the Discovery channels, they are seeing a lot of animals, they are getting the information about that, and they are day-to-day routine, they are getting the news and what is happening in and around the world like that. The newest generation of PCs operates microprocessors powerful enough to run video with the resolution of a television picture. So access devices based on software, we will call that as software agents, is being created to act as the consumer PDAs, personal data assistants. So operating system choice will depend upon the transport highway and user interfaces. If online services used PC-based access predominant, so for example, Windows 95 OS is well positioned here. Okay, now we are moving with different forms of OS. Okay, there is a great deal of uncertainty about the future configuration of access devices and so about the designing of user interface in e-com applications. So online browsing is not easy. Users have a menu of brief headlines, each for a story. Of often menu does not give enough information to make an informed decision. Also colors and layouts are not very attractive. So these early systems present first generation of online publications, and we will figure out how to design the effective interface with pictures or text or sound, movie, and probably smell. So in future generations, we are using the concept of artificial intelligence and deep learning in this particular part of design. So coming to the home shopping, the video on demand or other services present similar challenging. To make these services attractive, a consumer must be able to make the purchase decision in 4 remote control clicks. To tackle these challenges, 2 options are there. So we have to make 2 options in a prompt way, or we have to make 2 options in a proper way. What is software agents that act on consumers' behalf through voice commands, okay, like Alexa. So then we are having a broker, a machine that delivers consumers' typical preference to other computer systems in the network. This raises 2 issues. Okay, what are the issues we are having? So need for additional computer systems to track consumer preferences implies additional application and network cost is needed. So increasingly feature-rich software content implies vast variety of choice means increased chance of major software bugs implies damaged products attractiveness. The complexity of user interface design illustrates the gap between what seems obvious to application developers but makes no sense to the users. So whatever we are designing should satisfy the consumer perspectives, whatever the consumer is thinking and what type of product consumer want to receive, it has to satisfy that. So interfaces have to be very effective at recreating experience of browsing an electronic shelf to provide some sort of memory by association. So now the consumer, whenever we are coming to the concept of electronics commerce and consumer application, we have to deal with a lot of points, okay, starting from the consumer desires and what is the plan of the infrastructure and currently what is the application of choice, we have to look back. So in this session, we have seen the client-server architecture for e-commerce, multimedia contents of e-commerce, media convergence, and how we are moving media convergence and consumer access devices. What are the consumer access devices we are having and we are using for the communication of your data from one end to other and information delivery and transport systems. Thank you.